record. Okay, so Jose is here. We're gonna record this, but Jose wants to go through the tension problem. So I think I had provided kind of a description or a video of this, and 32. Yell at me if I do something wrong, Jose. 19, right? And this was 3 pounds of force in the downward direction. Yeah.
Yes.
Okay. Okay. So what we do, okay, for this is basically our free body diagram. We need to break all of these forces, the two rope forces, into their components. So I can rewrite this. Let's call this, and Jose did what I did. He called this force 1 and this force 2. And so when we break these down, and there's our right triangle, this is force 1 times the sine of 32 degrees. And this is force 1 times the cosine of 32 degrees. And then here, force 2. This is force 2 times the cosine of 19 degrees. And this is force 2 times the sine of 19 degrees. Okay, so I've got all of them broken down into components. The weight is just vertical, so I don't need to do that. And then I need to sum the forces in the x direction and sum the forces in the y direction. So the sum of the forces in the x direction is equal to 0 because it's not moving. And I write it as, and I'll highlight them, these two forces pulling in the x direction. Now they're opposite in direction, so I just make the F2 cosine 19. I'm going to make that negative. So F1 cosine 32 minus F2 cosine 19. So you're good with that, right, Jose?
Yes.
Okay, so then, oh, are you making food? Jose's making food. I got to figure out what he's making. So what are you making, man?
My alarm for Richmond went off.
Oh, sorry. I thought you were making food. I got really hungry. So I thought
Yeah.
it was the microwave. Okay, so because it's equal to 0, I can say this. If I move this to this side, I can say F2 cosine 19 is equal to F1 cosine 32. So those two forces have to be equal because, right, they're the only two forces that are pulling in the x direction. So, okay, we'll stop there on that one, and we'll do the same thing. Sum of the forces in the y direction is also equal to 0. And that's because it's not moving in the y direction. So I have 3 forces to add up. I have that one, and that one. And the weight is negative. So I'll say force 2 sine 19 plus force 1 sine 32 minus 3 pounds, right? 3 pounds is a force. So I'm not going to multiply by 9.81 because, okay, here's the thing, right? Pounds, that's a weight. It includes mass times gravity already. And then kilograms is just a mass. So I need to multiply by gravity if I was in kilograms. But since I'm in pounds, I'm just going to write it as minus 3. And of course, oh yeah, that one's equal to 0. So to solve this, I have two equations here. I have the first equation and the second equation, and I have two unknowns. So you could solve this however method you like. If you like doing this with substitution, great. If you like graphing it in Desmos, and I just did this in my other class, you could call like F2x and F1y. And you could graph those in Desmos, right? You could find equations y equals, and you could plot two lines and you could find where they intersect. But we're going to use substitution here. So let me get rid of those. What I'm going to do is I'm going to solve for F2. So I'm going to divide by cosine 19. These cancel. So this is my formula for F2. So what I can do, I can plug this right in there. So it looks like F1 cosine 32 over cosine 19 times, I had a sine 19. Okay, plus F1 sine 32 minus 3 equals 0. And how about, I know, Jose, I didn't do this yesterday when we talked about it. Do you know what sine divided by cosine or sine over cosine of 19 is? How can you simplify that?
Tangent.
Yeah, so I can write this as F1 cosine 32 tangent 19 plus F1 sine 32. And I'll move the 3 to the other side. Now we can simplify and solve. So I will factor out an F1 and cosine of 32 times tangent of 19. That's 0.2920 plus sine of 32. That's 5299. Okay, and I factored out F1. So that comes out to 3 equals F1 times 0.290, 2920 plus 0.5299. I get 0.8219 and then divide by 0.8219. And Jose, I'm not gonna, because I want my other class to do a little bit. So I'm not gonna give you the final answer, but right, whatever 3 divided by 0.8219 is, that is the force in pounds of force 1. And remember, force 1 was the right rope. Okay. Does that make sense? So you got to do 3 divided by 0.8219, and that comes out in pounds because 3 was in pounds. So 3 divided by 0.8219 comes out to force 1. And then Jose, once you've got that, and oh, if it helps in Canvas, I rounded to 3 significant digits. So your answer when you type it in should be something like that when you type it into Canvas as the solution. Okay, and then how would you solve for F2? What would you do at this point? You know force 1. So what would you do for F2? What do you think? I know it's a mess, but do you see a formula for F2? You're there, Jose?
Sorry, I meant I was saying that
okay, yep.
so you basically take the formula for F2 and just plug in force 1.
Yeah, so now you know force 1. Okay, if you really want to be precise, because we rounded force 1 down below, like I said, round to 3, you could probably use whatever your calculator said before we rounded and plug it into this formula, right? And multiply by cosine 32 over cosine 19. And then that should give you force 2. And at that point, then you would want to round. And I also wrote that one in as 3 sig figs. And just a heads up, when they come out to between 3 and 4 pounds each. So to suspend that weight, which was 3 pounds, I actually have to provide like somewhere between 3 and 4 pounds on both of those ropes or on both directions, because I need to have everything stay in static equilibrium. Okay. And so hopefully that makes sense. Now, I changed the quiz, so you just try it again, but have you tried it at the maximum attempts? Because I can change it.
I never really finished it.
Oh, okay. Well, okay. So go type in, get your answers for the courses, go type them in and submit a picture of your work, and that's it. And it's should be good to go, hopefully. And I double checked that everything's good in Canvas in terms of the right answers. So I think it should work. So do you feel okay?
Yeah.
The big part, I guess the thing that's the most practical and the thing that like we are trying to get you guys to build the best skill in is looking at that free body diagram and figuring out how many forces are really acting on that object. And if it's a diagonal force, it's really, you can think of it as two separate forces. Instead of one pulling diagonally, you're just taking it and breaking it into components. So the free body diagram, just by doing that, that's the bulk of the problem. And then solving out the algebra, it's easy to make mistakes in that. And like, I don't know, on a physics test, if we were doing this in person, if you set up your correct free body diagram, but made a mistake in the algebra, it'd still give you most of the credit, probably like 75, 80% credit. Just, the algebra kind of throws people off, especially when you start involving trig and factoring and all this stuff. So physics
I'm fine with
does,
the trig. It's kind of the algebraic stuff, like the
yeah,
extents.
yeah. And Newton's laws, the other big part, if you walk away from something in physics and you can remember this for college, things that aren't moving or things that are moving at a constant velocity, their net force is always zero. There's no like summed forces acting on, all the forces have to cancel, otherwise it would accelerate. So Newton's second law reduces to zero for things that are in, we call it static equilibrium. And a lot of things mechanical engineers design, bridges, roads, like signs, signposts, stoplights, every system like that is not supposed to move. And so when they solve these to determine how strong to make a post or a beam or how strong of a fastener they need, they use static equilibrium to help solve that. They use Newton's laws to determine the size of different pieces of metal to make these frames out of. So, okay, I'm gonna sign
Hold on.
off, but
Hold on.
oh yeah,
Can
what's
you
up? What's up?
can you scroll down to the Y stuff?
Yeah. I'm gonna stop recording.